All right, our next topic is homeostasis. This is a really important topic in anatomy and physiology. Make sure you understand what is homeostasis. Homeostasis refers to your body able to stay at a relatively stable condition regardless of the changes, whether if that changes is from the inside of the body or outside of the body. For example, your body temperature is normally at 98.6 degrees Fahrenheit. Your body is happy at 98 degrees Fahrenheit. This is the temperature that is optimal for your cells to function. That's why we don't want to have a fever for too long, because that would kill our cells. And when cells die, you don't exactly have a functional tissues anymore. When tissues go bad, your organ would go bad too. And as we go up the level of organization, bad organ means your organ system no longer works properly, and that leads to you not working properly. We get illnesses and diseases when our body cannot maintain homeostasis. That's why it's really important to keep our body at homeostasis. Let's take a look at this example here. Let's say when your body is getting warmer than usual. So here's the balance level, right? So you're increasing your body temperature. You're getting warmer. That increase in temperature is a stimulus or a trigger that tells your body something is off. It's like a signal, a warning signal kind of thing. And your brain is the sensor that senses the changes. In this case, the brain senses that there is an increase in temperature. The brain is also a control center, or the boss, that will give you or it will give the instruction to fix this temperature change. It would then tell your sweat glands to make sweat to cool off the body until your temperature is back to normal again, or decrease it until it's back to normal again. The brain also gives signal to the blood vessels to dilate or increase its diameter, so more blood can rush toward the skin and release the heat into the atmosphere. That's why when you're warm, you tend to get red, kind of thing. In terms of homeostasis, we have negative feedback and a positive feedback. In this example that we just described is a negative feedback, which is a mechanism that reverses a change from the set point. In other words, try to keep your body's level within their normal range. If you increases something, the response would be to decrease that, or vice versa. If you decrease something, then the response would be to increase the level back to normal. While negative feedback helps stabilize your body, positive feedback pushes you away from homeostasis. That means if there's a change from the normal range, that change results in more change, which causes even more change, which causes even more change. Why would your body want to do this, you asked? Well, one special condition or scenario, which is childbirth. There's not that many scenarios where your body uses the positive feedback system. But as I mentioned, childbirth is one of the popular scenario where positive feedback would happen. This is when the head of the fetus starts to push on the cervix. The uterine contractions begin. This causes the head to push even harder on the cervix, which results in more contraction. And it just keep go on and on until the baby is born. The positive feedback stops when the baby is out.